The firmware for the 502P SD card gadgety thing has moved on a bit, so I've got some extra screens here. So if I set that up, you type in a special number and then use the inverse save inverse exe option, you can see that I've got some help here. So these are the special numbers you type in to get different screens on the display. At the moment it's displaying help. Now I found out that when you press the AC key, you actually end up with a packet being, well, two packets actually being sent out of the interface. I don't really know why. I think it's a stop, so I think it's designed to stop printers and things if they're printing something or something like that. But I found that another key that does the same is the decimal point key, the dot key. And I've got no idea why it does that. That seems to send, I think it's a close, and it sends two packets. So what I've done is I've put in some decoding of those packets, which means to get the next display or the next page of help, you can actually just press the dot button and it almost instantly flips to the next page. And that's giving some help of graphics commands, so you can set pixels on the graphics page. That's the text help. I've added a text page so you can put ASCII text up on the display from the calculator, and that's back to all the different pages that you've got. So I think the status page 1.1 times 10 to the 40, if you type that in on the calculator, up pops the status. So that gives you the SD card reads and writes and the file number that you're dealing with at the moment. The graphics, that's as it was. Let's go back to the status help page. The graphics page, that's the same as it was. The memory, that is the same as it was, where you can display some of the memories in the calculator. I'll set that one up. We've seen it. You have to actually save the memories in order to display anything valid. These aren't valid values. It's just the RAM buffer within the ARM processor there. So if I do an inverse save exe, that will dump all the memories into the buffer on the ARM chip and they get displayed there. So if I go back to the status display, sorry, that's the help display, let's go back to the status display. So I'm going to load in a program, so I'm going to go to mode 3, clear everything, and then back to mode 1. I'm going to set up a file number, and so that's now read in from SD card, file number p510.dat, 274 bytes. So if I go to mode 3 and load that, that's come up with FP510, that's loaded off SD card. So now in mode 2 I've got a couple of programs, and they actually display stuff on the graphics screen. I can do that. Let's go back to the help and find out the number to use for the screen. Whoop, in mode 1. There we go. So graphics 1.2, so 1.2 times 10 to the 40, and that's the graphics screen. If I now press P1, that's now plotting from 127 down to 0, just random Y coordinates, so that's just plotting random dots. So I'll stop that. If we now go to 1.5 times 10 to the 40, which isn't on my help screen at the moment, this displays the program that is currently in the ARM buffer on the ARM chip here on the LCD display. So if I go to mode 3 and I do an inverse save, That will then dump all the programs into the RAM buffer of the ARM processor, and that's now been displayed as the tokens in text form that's in the calculator at the moment. So P0 is 1.2 times 10 to the 40, save, inverse XE, and so on. So you can see the program in text form, which is a lot clearer than having to scroll through the tokenized stuff. That's not all of it. There's more, and you use the dot button to get the next page. So it's a pretty big program really, and a dot button to get the next one. So what have we got? We've got P0 in there, and P1 starts here and goes on to the next page. So it's got word wrap, or strictly speaking token wrap, so it doesn't split tokens across lines. So label 0 will always be one word, and it will move to the next line if there isn't enough space to display it. At the moment it does split numbers, but I could maybe do some code for that. So you can just press the dot button, decimal point, and scroll around pretty instantly. It's a fairly slow display because it's being used, I'm using the software library to display stuff there, so that's pretty slow. But I'm quite pleased with that. That really does make it a bit more usable. If I go to mode 2, if I press the dot, you can press dot anywhere and it sends the packet out. Any mode, whatever you're doing, it seems to send the dot out. If I go back to P0 and then we have a look here on the calculator, so P0 is 1, and there's the 0, 1, EP is the point, and then 2, that's 1.2, EE is the exponent, and then 4, 0. And you can see that looking through these sort of encoded tokens isn't anywhere near as nice as just looking at that. And this is very similar to the 602. The 602 displays these text tokens. It's only really the well, there you go, save, invert, F1 is save, and then inverse E6 is shift XE, but it's actually inverse EXE. So I'm quite pleased with that, especially as you can, even here you can scroll around. Although now I've put 2 dots in the program, I've got to delete those. Well, that's the only downside, I suppose. The dot is actioned, but it's also sent out the interface. Yeah, so that's come on quite a lot. And I couldn't do this in the blue pill, there just wasn't enough flash. I think I'm up to about 85k or something at the moment. So that's not too bad. I've still got oodles of space, but it means that I've got enough RAM and flash to do these sorts of displays. But it was quite nice when I found out that you could use the decimal point to actually send a packet out pretty much instantly. I mean, it's a lot quicker than the cassette, the inverse save, inverse XE, because you don't have the header. There's no tape header because it's not a tape command. So I've got 2 buttons there I can use. I tried all the keys and they were the only 2 that sent anything, which is a bit of a shame really. There is some other traffic going on, but that's to do with the display. I think this connector here is actually on the bus, which means that any traffic that goes to the display controller is also on the bus. It's just that the chip enable for this interface isn't asserted. Unfortunately, it's a 4-bit bus and there's only one data line here, so you don't see all the traffic going to the display controller, which is a bit of a shame, because if you did, I mean, you could run wires in. If you did, you could have a mirrored display here of what's appearing down here, but I don't know how useful that would be really, considering these displays seem to last a fair amount of time. But there we go. Text program display.